It's one of the great ironies of our world, isn't it? We live on this amazing blue planet that's just covered in water, and yet fresh, clean water is one of our biggest challenges. It's a huge paradox. So today, we're going to dive into the incredible science that cracks this code, how we can take the endless salty ocean and turn it into a simple, clean glass of water.
And really, this is the fundamental question. With oceans stretching as far as the eye can see, how is it possible that anyone is thirsty? Well, the problem, of course, isn't about the amount of water. It's about the quality. It's just full of salt. But the solution? Now that is an amazing feat of engineering.
The scale of the challenge is just immense. Almost all the water on Earth is salt water. You can't drink it, you can't grow crops with it, and for decades, this is the exact puzzle that scientists and engineers have been working to solve.
And the answer they came up with is just brilliant. Instead of trying to invent some totally new, crazy process from scratch, they just looked at how nature already works, and then figured out how to flip a switch and run the whole thing backwards. Okay, so to really get how we pull this off, we've got to go back to basics for a second. We need to look at how water how it does its thing out in the wild.
And that natural flow, that tendency, is called osmosis. It's one of nature's most basic rules for keeping things in balance. See, water molecules will always try to move across some kind of barrier to dilute the saltier side. It's always trying to make things equal. You can really think of it as nature's ultimate balancing act.
So on one hand, you've got nature's way. That's osmosis, where water naturally flows toward the salt. But on the other hand, we have our solution, reverse osmosis. And what we do is apply a massive amount of pressure to completely overpower that natural flow, literally forcing the pure water molecules away from the salt. It's basically like winning an arm wrestling match against physics itself. So what does this actually look like inside a huge industrial plant? Well, let's follow a single drop of seawater as it goes through what you could call a high-tech gauntlet. It's an incredible journey designed to strip away everything that isn't pure H2O.
And this is the raw power that makes it all possible. 1,000 pounds per square inch of pressure. To give you some perspective, that's more than 30 times the pressure you've got in your car tires. This incredible force is the engine that drives the whole system, the brute force needed to bend nature to our will.
The whole thing is like a carefully choreographed dance. First up is intake, where big screens pull out obvious stuff like seaweed and fish. Then, in pre-treatment, a bunch of filters get rid of smaller things like sand and silt. After that, those massive pumps kick in, building up all that pressure and setting the stage for the main event, the membrane separation.
And this right here, this is the hero of the whole story, the membrane. We're not talking about some simple kitchen strainer. This thing is a true marvel of material science. It's the microscopic gatekeeper that gets to decide which molecules become freshwater and which get left behind.
And the specs on this thing are just mind-blowing. The pores in the membrane are just 0.0001 microns wide. That is ridiculously small, about 1,000 times smaller than a single strand of your hair. It's the perfect size to let those tiny water molecules slip right through while blocking almost everything else. We're talking 95 to 99% of all the dissolved salts, not to mention bacteria and viruses. It's a near-perfect barrier.
So our little drop of water has made it through the gauntlet. It's finally pure. But believe it or not, the journey isn't quite over. See, once the separation happens, you're left with two very different streams of water. And here's the split. The good stuff, the water that made it through the membrane, is called permeate. I like to think of it as the water that got permission to pass. That's our fresh water. Everything else that got left behind gets concentrated into a super salty liquid called brine. Now this brine usually just gets sent back to the ocean, and managing that is a huge environmental part of running these plants.
So you'd think, okay, great, we're done. We've got pure water. But here's the funny thing. The water is actually too pure. It's not quite right for us to drink yet. It needs a few final finishing touches before it's ready for your tap.
This final step is called post-treatment. Because the water is so pure, it's a little bit acidic. So first, they have to stabilize the pH. Then, and this is super important, they actually add back some essential minerals like calcium and magnesium. That's not just for our health, it also makes the water taste right. And finally, as a last safety check, it's disinfected with either chlorine or UV light before it's sent out to the public water supply. All right, let's zoom out for a second. This technology isn't just a cool science experiment. It's happening right now at a massive scale around the world, providing fresh water for millions of people. So with that in mind, What does this all mean for the big picture, for the future of our planning?
It really all boils down to this one powerful idea. It's a sophisticated, clever piece of technology that takes a natural process and just flips it on its head to get rid of salt and all the other junk. It's a perfect example of human ingenuity solving a fundamental problem.
Which leaves us with this final, really thought-provoking question. As this technology keeps getting better and more efficient,